Hello, class. This will be the recorded lecture for the next section in chapter 12 here, which talks about two more tests that we're going to do for qualitative data. And so we're probably going to split this one up into three different, maybe even four different recorded lectures. And the book does a good job at the beginning of this section, so I'm going to follow it, lead quite a bit here. And so we're going to talk about the test for independence and homogeneity. And so what we'd like to start with is a quick introduction on how we actually get this set up. And the data is going to be provided in tables. So you'll see that the spreadsheet is going to come in super handy in these calculations. And even when we do the test statistic calculation, I'm going to show you how to use the spreadsheet as your calculator to get through all of this. And so, but before we do that, let's talk about this idea of what the book calls contingency tables. And so in this idea, we have two different categories. First category, our study. Second category, majors. And so this idea of 1,000 college freshmen, our study for these four majors. And they split the categories up into 0 to 10, 11 to 20, and then more than 20 hours per week. And so one of the questions might be, are these two independent of one another? And we're going to show you how to do that statistical calculation. But before then, we're going to end up with some more definitions. So the row variables and column variables, that's what they call them. And most books have it set up that way. And so the row variables, in this case, we have three of them, right? And those are the hours studied. And the column variables, we have four, and those are the majors. And so one of the things that we're going to need to do in this calculation is to be able to find the total of each row, the total of each column, and the grand total, which we are given here as 1,000. And so you can see where the spreadsheet will come really useful with regards to organizing all this. And we're going to use this example for the example that I will show you how to do in the calculation. But before we do that, let me set up the idea of what we need to do. And the idea of independence, if you remember back, back in our probability discussion, we would say, say you have two events, A and B. Two events are independent, right? If the probability of A and B does what? Equals the probability of A times the probability of B. Whoops. And so what we're going to do is to use this idea of independent definition using probability and assume using the hypothesis testing that it is independent, and see if we could run this idea of a chi-squared test statistic comparison to either reject or do not reject the null hypothesis. So this is kind of the basis of all this. And the book goes through a really nice kind of informal derivation on what we're doing here. And again, with regards to this example, we would set the null hypothesis for it being independent and the alternative not being independent, or you could use the word dependent as well. And so we're going to walk through this and say that if we reject the null hypothesis, that it's dependent or not dependent. Or if we do not reject, we really don't have a conclusion in this case. So those are the two options. So the null and the alternative hypothesis for independence is always set up this way, which is nice. And so this book comes up with a nice little idea of derivation, right? And so if we want to calculate what we're thinking about as these expected values. And they use the term expected frequency, which is what we're doing, right? This idea of occurrence. And so if you wanted to calculate the expected value of two events, and so in this case, the example that the book is given is a probability of 0 to 10 hours, and then times the probability of being a humanities major. So if we go back to our whiteboard here, right? If we set A equals to 0 to 10 hours and B equals humanities, right? So that's what we're looking at. And the idea is we want to make a calculation that looks like this, right? And so again, by our null hypothesis, we are assuming that it's independent. So we can do this calculation. And so if you go back to the data, you could see that with regards to 0 to 10 hours, there's a total of 345 students, right? So what's the probability that out of the 1,000, 345 of them studied 0 to 10 hours a week? 345 divided by 1,000. You see that right here? It's this calculation right here. And then the same with humanities. There are 257 humanity majors. And what is their probability? Well, you divide by the total. And so if you multiply these two together, you would end up with the probability of 0 to 10 hours studying and humanity majors if the two are independent of one another. So if we take a look at this calculation again, so the probability of A was our 345 divided by 1,000, which would be 0.345. And then the other one is there was 257 humanities students times 1,000. So if you do that probability calculation, it would be 0.8866. And so this is the probability, right? Little over 8% that both of these occur if these are independent events. So 8% of our total population, well, what's our total population? Well, our total is 1,000, right? So how do we find the expected value? Remember, it's the probability times the total. So this would be, this is not right, sorry. It's P of A and B. And so if you do this calculation, it would be 0.08866 times 1,000. And so that would be 88.66 total number of expected students to be able to study between 0 to 10 and be a humanities major. And so the idea is that this is going to be the start of our test statistic. And if we go back to the, here we go. This is the expected value. They use the word frequency. And so we are going to give you a formula for the expected value. And it's the total for the rows times total columns divided by the grand total of 1,000. I could show you the algebra, but it works out quite well. You're not responsible for the algebra, but you are responsible to make this kind of calculation. And so in the next recorded lecture, we're going to walk through the steps for this calculation. And here it is right now, a 6-step approach. So, but that's going to be a little bit detailed and long. So I think it's good to stop this recorded lecture. And like I said, in the next one, we're going to walk through the calculations.